Good day to judges, ladies and gentlemen. My name is Teo Pauter from Faculty of Bioengineering and Technology, University Malaysia, Kelantan. Today I would like to pitch for our inventions entitled Green Porous Ceramic Thermal Insulator made from wood sawdust waste. Ladies and gentlemen, what is wood sawdust? Wood sawdust is one of the major waste generated from wood exploitations and processing such as sawing, milling and cutting. The sawdust is generated in large quantities by the current growing wood and timber industry as well as furniture factories in developing countries including Malaysia. Conventionally, the wood sawdust is widely used in medium-density fiberboard (MDF), furniture, solid fuel for heat boiler as well as some eventually goes to landfill for disposal. However, those applications and efforts are still insufficient to cater the huge amount of wood sawdust generated every year. So, instead of dumping the remaining wood sawdust into landfill, why not with sustainable transform it into green ceramic product? In fact, this is also well aligned and supporting the UNESCO Sustainable Development Goal SDG, Goal number 12, Responsible Consumptions and Productions. Therefore, these inventions have successfully recycled the wood sawdust waste as one of the raw materials for green porous ceramic thermal insulator, also known as green PCTI. Ladies and gentlemen, why wood sawdust? What is the functions of the wood sawdust in porous ceramic productions? The wood sawdust act as pore-forming agents to induce the formations of well-controlled level of internal porosity in the porous ceramic. Subsequently, the pores will reduce thermal conductivities of ceramic, contributing to the thermal insulating properties. Currently, solid wastes such as wheat straw, corn cobs, maize seed, wheat seed and rice husk ash are used as the pore forming agents. However, those wastes have inconsistent particle size distributions, leading to inconsistent porosity, mechanical strength and eventually inconsistent thermal insulating property. Furthermore, the wastes also have high ignition point and thus leading to energy inefficiency in productions. Therefore, in these inventions, wood sawdust has great potential as pore-forming agents for the ceramic thermal insulator due to the dust has fine and uniform particle size distributions ranging from 1.5 to 63 micrometer. In addition, wood sawdust also has a much lower ignition point of approximately 118 degrees Celsius. Hence, a much lower of firing temperature is applied to ignite the dust and eventually forming pores. Subsequently, this capable to reduce embodied energy as well as carbon footprint for the productions of porous thermal insulator. Now, the next question is, why do we essentially require the porous ceramic thermal insulator? Where do we use it? And why do we prefer the eco-friendly thermal insulator? Looking at the market demands, thermal insulator is mostly used in refractory ceramic, building and construction industry. The thermal insulator market is projected to grow as much as 5.3% in year 2026. Also, consumers are currently progressively options for eco-friendly and sustainable materials by recycling and incorporating waste materials into it. In this case, the porous ceramic thermal insulator incorporated with wood sawdust waste is an excellent option. Therefore, this invention came at the right place and right moment to cater the industry demand. Ladies and gentlemen, this is the processing routes to produce the porous ceramic thermal insulator. We are employing the simple powder compaction methods integrated with spray drying process. This process is similar with what has been practiced by the worldwide ceramic industry. So this is how the porous ceramic thermal insulator looks like. This is the summary of the successful journey of the inventions. We have named the product as Green PCTI. In overall, we are now at the stage of TRL4. With the collaborative works with ATEC Taiping, we have successfully developed the small-scale porous ceramic thermal insulator at laboratory scale. Subsequently, we will be proceeding with the higher TRL5 and above for large-scale prototype and testing the Green PCTI at simulated and actual applications. On top of these successful inventions, we would like to precisely highlight and emphasize that the novelty and uniqueness of these inventions are based on three criteria. Number 1. Thermal insulation. The Green PCTI has well-controlled porosity level, leading to its consistent and lower thermal conductivity of as low as 0.06 watts per meter Kelvin. Number 2. Porosity and non-hazardous. The Green PCTI has porosity level of 40 to 45% comparable with the commercial ceramic-based thermal insulator. It has passed leaching tests and non-hazardous despite of made from wood sawdust waste. Last but not least, number 3, the Green PCTI is environmentally friendly. It consumes lower embodied energy during production since lower firing temperature is employed and it is recyclable. Ladies and gentlemen, considering the novelty and uniqueness of the Green PCTI, so where can we use it? The Green PCTI can be used specifically for thermal insulating purpose such as for roof shielding and wall shielding in high-rise buildings, houses and factories. Well, why do we confident that the Green PCTI can be well accepted by the building and construction industry? To answer this, let us look at the technical specifications and price comparisons between the Green PCTI and commercial thermal insulator. Based on the technical comparisons, the Green PCTI is an overall winner in terms of lower thermal conductivity, higher compressive strength, comparable porosity, zero VOC, non-hazardous, recyclable, and as well as lower firing temperature for energy efficiency in productions. In overall, it is also among the cheapest than others as the pore forming agent is a waste materials which is the wood sawdust waste. On top of everything, we would like to convey our heartfelt gratitude to University Malaysia Kelantan for awarding UMK Prototype Grant for the developments of the green PCTI. Along the invention journey, we have successfully published 2 Web of Science WOS Q1 and Scopus Index journals. And not to forget the 2 final year projects undergraduate students Muhammad Lokman and Nur Atika, as well as the Master Science student Afikah Awang Kecil, that have contributed to the successful of the green PCTI invention. We are also glad to share with you that we have successfully filed the patents of these green PCTI inventions on July 2021. We are also working closely with ATEC Taiping to upgrade and upscaling the green PCTI to the higher level of TRL of 5 and above. We are on the road and progressively moving to the full product commercializations of TRL number 9. Ladies and gentlemen, to conclude the pitching sessions, let us look at the overall innovation impacts in terms of quintuple helix of the green PCTI inventions. The successful of these inventions would reduce waste disposal costs of wood and timber industry, as well as reducing raw material costs of the thermal insulator industry. It will ensure a much sustainable and greener recycling of the wood sawdust waste and reduce dependency and explorations of natural resources of raw materials for the porous ceramic thermal insulator productions. Both these would benefit the environment. As for us UMK academic institutions, it creates new recycling knowledge to us and producing new young talents graduates, as well as strengthening the linkages with others agencies. We are glad with the opportunity to collaborate and share the green PCTI productions technology with ATEC Taiping. As for community, we are now working on the knowledge transfer programs to the Kelantan local and SME furniture entrepreneurs and carpenters, so that we could guide them on the possibility to recycle the wood sawdust into new valuable products, and this would generate side incomes for them. Last but not least, I would like to acknowledge and thanks to all the team members for contributing to the successful of the green PCTI inventions. Without them, the green PCTI will not be as successful as today. That's all from me. Thank you. Have a nice day.